All right, session 7. Let's think about how we choose drones for particular missions. All right, so what are the important aspects? Endurance is one. How long are you going to take to do this? We're limited with battery power with most multicopters, so we have decisions between fixed wing and multicopters, depending on how long the flight needs to be. Um, that's just one issue. So we need to be able to make some choices. Short range maneuverability, hey, multicopters win the day for that. Fixed wing for long range or pattern flight missions or delivery is probably going to be helpful. Well, it depends on what kind of delivery. We also have choices about what kind of image we're going to take, whether we need thermal imaging or whether just we're taking pictures of ground or artistic possibilities. So that's what we want to sort of concentrate on today. Um, this is just this video here um, talks about a specific kind of drone. The video probably won't play, so you'll need to do the QR code and watch. So you might want to pause it, watch the QR code, and consider what they're doing here. What they're doing with this kind of drone. I found it very interesting flying in a cave or a mine in this case. Obstacle avoidance is a big deal. So he'll explain some of those things in the video. It's a YouTube link. It's safe. Okay, so we have different components in a drone. One of the big main ones, the one that's made this technology available, is mini computers, miniaturization capacity, etc. So flight controller is like the main brain of the drone, translates those inputs from your little controller on the, that little picture on the bottom. No, the other way, that way. That little picture there, you know what that is. So it takes your inputs and then translates it to the different components. It also accepts components as well. Fixed wing drones don't need this necessarily. They need part of it, but not all of it. They'll need, because they're not controlling 4 different motors to maintain stability. Fixed wing drone has its own built-in stability because of the wings and the tail and all those things. So we'll talk about that a little more as we go along. But flight controllers for multicopters necessary just because of the instability factor with them. So what's a flight controller do? Flight controllers control, basically receive input and send inputs out to the electronic speed controls, which send appropriate amounts of voltage to individual motors. Again, fixed wing drones don't require that because they have built-in stability. There's at least one motor, perhaps 2, that need to be controlled, but typically it's just forward motion, either increasing the motion, keeping it static, or reducing motion or thrust. Most flight controllers will have advanced functions. Um, return to home, autopilot, optical avoid, those kinds of things. But in order to do that, they need components that feed information into the flight controllers. Okay, so there's a few of these functions. Internal measurement unit, right? So it needs that, and we're going to talk about this in a second. We need a GPS, some kind of a compass, and memory for flight data, right? We have flight plans that we upload, so it has to have some place to store that. So you have to have some kind of onboard memory. GPS. Okay, so we'll back up. And of course, all of the devices are fed to the flight controller to maintain stability and to monitor itself, its performance, and to perform automated functions. GPS, we've talked about this before, but again, just a reminder, just a review, it uses that whole constellation of satellites that the United States, European Union, Russia, India, China, they've sent up satellites, and we're all sharing data apparently. Trilaterate position, right? Remember the different circles, that's the intersection of these three, at least three satellites will give us the information laterally and also vertically. They're saying the GPS is accurate within 3 meters or less. It's probably better than that, but it all depends on the day, it seems like. GPS cannot determine heading or orientation, only ground speed and vector. And fixed-wing drones, again, they need a pitot tube system because they need airspeed in order to maintain airflow over the wing to prevent stalls. We'll talk about that again in a minute. Okay, so, and we've talked about this as well because we've had to do it. We have to sometimes calibrate the compass. Magnetometer manages the drone's heading. Okay, it's calibrated to true north. Before a flight, we probably, especially if we're going to be professional pilots, we need to be actually doing this every time before a flight. This is a picture of one here, and I did want to annotate this because there's something important here in addition to the unit is this little plastic thing right in here. Now, your multicopter doesn't have this, but if it's a fixed-wing drone, it will have this. And what it is a pitot tube, basically. This one, and I don't know which one is which, but I'm just going to, for example, first I'm going to erase this if I can, because I drew right over the top of what I wanted to draw. Okay, this tube here takes blasting air into, as it's moving forward, air blasts into that little hole there. This little hole here is static. In other words, it doesn't have any air blowing into it or sucking out of it either way. It's inside the compartment, so it just is measuring ambient air pressure. Well, the difference between the ram air and the static air is how fast the drone's going. It's simple, just like if you're driving your car, you stick your hand out the window. If your hand is, you can feel how hard the wind is blowing because that, depending on how fast you're going. That's a pitot tube, basically. But anyway, that's the magnetometer, which is not that easy to pronounce, but that's what it is. Okay, then we have the IMU, internal measurement unit, sometimes called an accelerometer, measures the movement and velocity changes of the drone. So it's acceleration, basically. Okay, and that's used by the flight control as well. The GPS is used by the flight control. Airspeed used by the flight controller if it's a fixed-wing drone. IMU, or accelerometer, is fed to the flight controller to ensure its stability as well. In addition, especially if it's a fixed-wing drone, but not necessarily on a multicopter, but this data may be displayed back to your controller to give you an artificial, so you can see whether it's banking or pitching or up and down, give you sort of an attitude indicator, or an artificial horizon, they might call it, as well, in addition. Okay, then we have power management units, PMUs. Okay, we love the acronyms, right? PMU sends power usage data for each component to the flight controller. So we'll see a diagram here in a little bit, but for now, just be aware, the flight controller needs to know that, how much power is being used at any particular moment, because it's going to need to make some calculations about minimum power. At some point, when the batteries gets at a certain point, it will trigger the return to home, or other things may happen depending on your programming. In addition, there's also telemetry units. That's a separate unit. Telemetry units manage the communication between the drone and the ground control station. Okay, so yeah, you have to have something. It has to receive the radio signals from your ground control unit or station. Also, it needs to transmit stuff back to the ground control station that you're holding in your hand, right? Well, the video for one thing, and also speed and all those other things. A lot of things you receive, but you need a telemetry unit. Telemetry unit may be external, like this one here, and sticking up like the Mandalorian has. Most of them have some kind of a telemetry unit on their helmet, right? Or it may be internal, like this one here. Telemetry units, it's basically a radio frequency. Usually it's line of sight, so if you get too far away, it won't connect very well. That's why we have those triggers, automated triggers, where if you lose connection between the ground control station and the drone, it will, if it's doing some automated flight plan, it'll finish that automated flight plan and then fly back. If you're not, if you're just flying around, all of a sudden you lose connection, you don't need to panic, because it's going to, perhaps it'll wait a little while and try to reconnect, or maybe it'll just immediately go to the return to home altitude, fly back and land in front of you. Or sometime during that return to home feature, it'll get reconnect, and then you just continue doing what you're doing. Anyway, it's all line of sight. Well, that might be a problem. How about if we want to deliver a boxcar drone full of peaches from South Georgia to Atlanta, 100 miles maybe. How are we going to keep connection with it? What's going to, okay, well, there's solutions. Obviously, there's going to be solutions. One of the solutions is 5G. If it's got a 5G connection the whole flight, assuming we've got permission, obviously, beyond line of sight, permission or waiver or whatever, they'll be able to continue to connect to your ground control station throughout the flight. Wow, that's a lot. Okay, we also have range sensors. So we have GPS receivers, got the compass or magnetometer. We have the, if it's a fixed wing drone, some kind of pitot tube. We have the IMUs or accelerometers. We have the power management system. We have the telemetry, but we also have these range sensors, okay? So this is like a sonar module. It bounces, well, like the dolphin, right, or whales, right? Or the bats. That's probably even more related. Avoiding obstacles, yes, but you can imagine it has to be a fairly large flat surface in order to echolocate. So it's mostly used for above the ground, shutting off the motors when landing or descending. It's crude, not that specific. Depending on the surface, right? It may be like a lot of these drones, if it doesn't get a good landing signal off the ground, it says, wait a minute, this surface is not appropriate. We can't land here, so it'll hover until you fix whatever the problem is. Then we have the optical flow sensors. They're basically cameras, low quality, typically low quality, but it could be better quality. There are some drones that are very good with obstacle avoidance, so they must probably have better cameras, but they're pointing all different directions, depending on which part of your drone. You have to do that research yourself. The EVO 2 Pro, we've tested that, extremely good sensors for obstacle avoidance. I warn people that for twigs and wires, that typically obstacle avoidance doesn't work that good, but I was pretty impressed with that drone. Anyway, it depends on the surface, of course, how well it works. And for landing, if it's a surface that has no markings, it's just bland, flat, consistent color without any kind of thing to compare, it doesn't work too good. So losing a landing pad helps in that situation. Water is also a place where you can get into trouble. If it's a fairly low quality camera that's used for landing assistance, water can be, if it's flat water especially, it can deceive it, and it won't know that it's how high it is above the water, and it may settle into the water. That seemed to be a problem. It hasn't had, that's less likely nowadays. It used to be a bigger deal. Optical flow, so that's basically optical, that's camera. Some kind of a, basic camera. Not going to be good enough to take good pictures, but enough to sense how far away it is from. All right, this is a flow chart of the power input output information for mostly for a flight controller, but Hexun TD650 is a particular drone, and this is just you know when you make your own drone, you'll have something like this to work off of. This is pretty generic, but anyway, let's see. You can see the flight control in the middle. You can see the arrows pointing in and out, so you can sort of go where you can sort of figure where I'm going with this. GPS, magnometer, optical flow sensors, LiDAR. LiDAR is, we're not talking about LiDAR mapping. It's LiDAR just as a visual sense of obstacles in the area. So that in this particular drone, they're using this for the optical sensor to determine optical avoidance, landing information. So all that information, you can see the arrows are going into the flight controller. The flight controller is going, okay, well, this is so I need this information to process to maintain stability. We also have down here, we have the control radio. That's the ground control station, right? That's going back and forth. Information being sent to the flight controller, and flight controller sends information back to you. It doesn't do it like directly because it needs to be connected to the telemetry unit. So somehow they're also connected there as well. But the telemetry unit is taking the information that you're telling the drone. I'm telling the drone to do this. Telemetry sends the information up to the flight controller. The flight controller then says, okay, I'll do that. And it sends the information back to the telemetry radio to go to the control station so you know it's doing what you asked it to do. Telemetry also handles the video and the pictures, that kind of thing. Okay. The flight controller, from the information it receives from these sensors and from you, and sends the information to the ECS, electronic speed controller. Electronic speed controller number 1 controls motor number 1. And we've talked about that before. Remember the motors? The motor number 1 goes clockwise, motor number 2 goes counterclockwise, right? They've got to go in opposite directions to keep the, yeah, okay, we talked about that. So that's how that goes. That's how it keeps, that's the amazing thing. It's got to control all 4 motors at the same time. I can only do 2 things at once, and not both of them I can't do well. I can do 1 thing at a time really well. I can do 2 things at a time, but not that good. If I try to do 3 things at the same time, my brain goes, nope. But the flight controller does all 4. Or if it's got 6, if it's, you know, got 6 propellers, there's 6 motors, whatever. So that's basically what it's doing. That's the schematic there. Flight controller also sends some of this information that it's received from you or from an automated flight plan out to the gimbal, because you're asking it to tip up and down, right? It's also sending some information and commands to the camera controller. The camera controller sends it to the camera sends it to the video transmitter. Video transmitter is sending it to you. May or may not be using the telemetry radio to do that. Most likely it is. Okay. Right, so you sort of get that, right? So the flight control is handling the motor speeds according to whatever demand is and whatever instability might be happening, gust of wind or whatever. It's also controlling, receiving your information and sending it to the gimbal and to the camera. And then the camera is either itself for its own transmitter or telemetry radio to send it back to you. What we could have started with, which we didn't, but we're going to go back and do that now, is what about the battery? Okay, there's a battery here. It goes to a current sensor. A current sensor is just, as I understand this, it's if there's some kind of an odd amount of power, it will massage that so that it's the proper amount of power being sent out, or interrupts it if it's wacko, like all of a sudden it's got a short or sending too much power, it can interrupt that. That will send power to the flight controller 5 volt. Well, of course, it's got 2 volts, at least 2 different voltages, the 5 volt side and the 12 volt side. And some power distribution boards may have other limits as well, but it divides it up. No big deal. Don't fret about that. But that 5 volt will send it to the flight controller to operate that. And in this particular situation, 12 volt goes to the actual gimbal, maybe because it requires more, because it's got little electric motors that's got to control it. I'm not sure why. That's not important, in my opinion, for your understanding right now. You know, if you are going to build your own drone, you'd use something like this thing, and you just want to make sure to hook up the gimbal to the 12 volt side and not the 5 volt side, and make sure you're not hooking, you know, it will specify what you need to do, because you're going to need to make some decisions about which wires go where. It's really not as complicated as it looks, but it does require some precision. Now, you might be in your mind be thinking of a lot of soldering, but they do also make flight controllers that don't require soldering. They just snap in, but just so you know. This also raises the question, well, why don't I just build my own drone? It'd be a lot cheaper. Apparently, it's not that much cheaper. And building the drone is fairly inexpensive. But then adding the camera to it and the gimbal, that turns into a lot of money. So decide for yourself. You might want to do this as a project on your own, because you can buy them. There's online sources to buy all of these elements. And if you got a 3D printer, you can make your own aircraft body. That's not beyond the realm of possibility, sure. Okay, so that's basically the schematic to give you an idea how these components, we've talked about GPS, talked about magnometer, optical flow sensors. We talked about all those things, so so we're going to move on, though. We're going to talk about some other things as well, if I can get to the next slide. So let's think about payloads. We've got to the part where we get the input, but we need, 90% of what we do, or more than 90% of what we do, has to do with some kind of image. So we need a payload, a camera, or some kind of image sensor. That's one possibility. Depending on what we're doing, whether it's surveying or reconnaissance or first-person view, they all require some kind of different configuration. So we want to explore that. Remember that FPV is a camera view from the perspective of the UAV, so it will show banking information and pitching information. It's the way the camera will be orienting. And you've seen those FPV videos, I'm sure. FPV video cameras vary in price and versatility. It all depends on what you're trying to do. If you just want a really cool, speedy, or if you're just doing drone racing, you don't need really high quality pictures, right? You just want to know the orientation and to avoid the pillars or the circle, whatever. Anyway, you as the operator, as the one who's going to be operating these things, you need to make some decisions about what data needs to be collected, quality, trigger rate, all those things about the camera. Okay. So the camera is an important issue, but also how do you mount the camera or whatever you've got, right? You could just take a camera and stick it to the side of the drone, but you actually that's just going to give you one view depending on which way the thing's turning. So a gimbal is like the most sophisticated. Shock isolate just means it doesn't record the vibration of the aircraft as motors are turning. It will require gyroscopes. We'll move on all 3 axes through a wide range of motion. Right, and we're familiar with all that. That's not a big shock. But then we have another kind of gimbal, which is just movable. So it does not have the little motors. It doesn't have gyroscopes. But you're holding the drone in your hand. You can turn the gimbal so it points in a specific direction. So it's movable, but it has limited motion. And then, of course, we have fixed. It's possible to have a fixed mount with a camera, I suppose, like for FPV. If you're doing drone racing, you'd probably want to have it fixed. It's probably the most secure way to do it. But typically it's just used for mounting antennas or lights, or if you're doing agricultural pesticide or dropping seeds, you don't really need a gimbal mount. You just want it to drop the seeds as you fly over the ground. Fixed would also possibly work. Well, it would definitely more for antennas and lights, really, is the main reason. Okay, so what if we're going to do surveying? As we know, typically it's done by some kind of downward image of the Earth's surface, and then the software we have stitches it all together into a map. Can be done underwater also, or underground, I suppose. That earlier video, if you've watched it, at the very beginning, it talked about doing a LiDAR map of the tunnel or the mine so that the inspectors can look at that and see that looks suspicious, like that's going to cave in and, Big Bad John's going to be buried for life, that kind of thing. But for surveying, you need a camera or something that makes an image, right? You can use a fixed or movable sensor mount because you're just keeping it pointing straight down or at an angle. And you, of course, need a trigger mechanism, which would, again, be transmitted from the ground control station to the flight controller. The flight controller will send it to the camera controller. The camera controller will send it to the camera to click the picture as it goes along. Click, click, click as it's flying along. Make sense? Yeah. Now, if you're doing FPV reconnaissance, you just want to see what the drone is seeing and be able to point it to wherever the bad guys are. If, I don't know, a fire or whatever, you would definitely need a camera, of course. We need some kind of you want a gimbal sensor mount because you want to be able to change the angle that you're pointing the camera, but you need the video transmitter. You got to get the information back to the observers. You're there with your control. You're the police officer. Let's say we'll use that as an example. Now, I like the other example. Fire department. You're hired by the fire department to be on site to get a high-angle picture of this fire. You may have thermal imaging, you may not. It doesn't matter, but you want to try to get us sort of so that everybody around you knows what's going on at the fire without actually standing in the fire. So anyway, the fire chief is behind you, then you got a couple of guys standing behind you looking at your little screen over your shoulder. Well, that's just not going to work. That's not what you need. You need some way to receive the video information and then transmit it from your ground control unit to another display. We'll talk about that a little bit in a minute. But this is something that you would need for that. FPV cameras, live video from the perspective of the UAV. This is for racing. We're talking about pilot camera just faces forward, so there could be a fixed. But you also still need the flight telemetry to be displayed, so you see where the obstacles are that you're racing through. So that's another kind of thing. Okay, this is where I was going with that story about the fire department. So you're standing there. It just would not be efficient for the fire guys behind you to have to come to your place to decide what to do. So you need some way to transmit it from your ground control station to another video station in the back of your pickup truck, or maybe at the station, or maybe it's a command vehicle. So, an HDMI cable, maybe that doesn't make sense, but an HDMI, Bluetooth, or Wi-Fi connection to be transmitted to the command station. And I know of at least one fire department that has that transmits that video to the internet, to a website, so that the volunteer firemen that live in the next town, as they're driving to the site of the fire, they can look at their telephone and see what's going on. So when they get there, they already know what's going on, what needs to be done. Okay, so let's just take a quick little quiz here from what we've already, sort of like a review, not really a quiz, but just a quick little quiz. Let's consider that. What's the purposes of a flight controller? It takes those inputs, sensor inputs, from your command, but also from the attitude and the heading and the GPS, and it sends that information to the electronic control units so that it can turn the propellers at the appropriate RPM so that it will provide stability. Does a multicopter need a flight controller? Yes. Why? It's basically unstable or has no stability of its own. Okay, what type of payload might you need for surveying? You need a camera, obviously, some kind of a trigger mechanism to make it click, 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 click the pictures as it's going along over the thing. Of course, it would need, I already said GPS, didn't I? Yeah. What type of payload might you need for reconnaissance? You'd want a gimbal to mount, and obviously a camera and a way to transmit the video back to a monitoring station somewhere. What for sensors, primary sensors do flight controllers require to operate? Okay, well, internal measurement units, IMUs, power management units, PMUs, some kind of range sensor or optical flow, LiDAR kind of optical sensing for landing and knowing when to shut the motors off when it does land. So that's typically what's on most of these drones. Okay. I'm going to stop this video, and that'll be part 1, and then we'll go to part 2.